Celsius is a 4-year NIC funded innovation project that ran from 2016 to 2020, and the aim of Celsius is to understand the thermal performance of distribution transformers with the aim of releasing additional capacity without the need for costly reinforcement. So we installed monitoring to 520 distribution substations. They were a wide range of substations which represented the entire population of our substations, and from that monitoring we got various temperatures from around the transformer and the substation. We got loads and voltages. Additional monitoring added to the substations gave us a better understanding of the thermal rating of the transformers. So from that we could actually put more capacity through the transformer without needing to do any reinforcement. So it gave us a new rating, a Celsius rating, rather than the nominal nameplate rating which we currently use. So our existing strategy for replacing transformers has worked perfectly up until this point, because when the new transformers are installed they have a little bit of capacity headroom to allow for natural growth, load increasing over time, people getting more and more electrical appliances and the likes, but that has also been counterbalanced with appliances becoming more efficient. The challenge we face now is that we're going to see an unprecedented load increase over the coming years, with people buying electric cars and moving towards electric heat pumps. The load is going to go up at a rate which we've never seen before. So all that additional capacity headroom is going to be is going to go very quickly. So what Celsius will do is allow us to properly understand how much headroom we have, because when the nameplate rating is given to a transformer, it assumes a worst case scenario. And what we actually have is a wide variety of environments in which our transformers are situated. So from that we can release additional capacity without having to do any reinforcement, and we can also add in other measures such as different cooling techniques which will give us additional capacity still. And all of this should allow a quick and easy connection of low carbon technologies without the need of replacing transformers, or certainly to defer the need until a later date, which gives our asset management team better understanding and more time to plan for the investment plan. So one of the key features of the Celsius project was the thermal ratings tool. So in the first instance, the thermal ratings tool used the data we got from the trial, and it gives you a basic drop-down menu where a design engineer can take the basic information from a substation, the building type, the KVA rating, the spec of the transformer and so on, put this basic information into the tool, and it will provide some estimations as to how much of an increase you will see from the various Celsius technologies. So that's a very useful starting point for a design engineer to work with. And on top of that, once the monitoring has been installed, you can then download the monitoring data into the thermal ratings tool, and that will provide you with a new rating for that transformer, which we've called the Celsius rating. So then you can operate your transformer up to this new rating and it'll still be within the temperature ratings specified by the manufacturer. When we installed the monitoring equipment, that gave us an understanding of the thermal performance of that substation, and in the majority of cases that gave us more capacity than the nominal nameplate rating. On average over the project it was somewhere in the region of 30% increase. As well as that, if we need additional capacity on top of that, we've also got the option of adding cooling technologies. So we had a number of cooling technologies throughout the trial. We had 2 active cooling technologies which are powered units. So the first one was a fan unit that pulled in ambient cool air from outside the substation and forced it into the substation to cool the transformer down. And the second one was the opposite of that, so it extracted the hot air from directly around the transformer area and expelled it to the outside of the substation. We also had a number of passive technologies such as additional vents. So this is just adding additional vents into the substation or moving the existing vent into a more optimal location to give maximum airflow over the transformer. We had solar reflective paint on outdoor substations. On a similar vein, we had some shading structures that we put over the top of transformers for the same reasons, to prevent the solar gain. And the final one we trialled was a cable backfill material different than what we currently use, so a higher thermal conductivity material. From them, the active cooling technology units proved very effective, and in the majority of cases we saw between 10 and 15% additional capacity on top of monitoring alone. The additional vents were a bit more of a mixed picture. The issue with that was the starting point for the substations was all slightly different, because the nature of substations are all different types of buildings, different layouts, so it varied depending on the starting point. The reflective paint, some saw improvement, some didn't, so it was a little bit inconclusive as to how effective that was, and the ones that saw improvement were only minor. The shading technology provided very little benefit, and in fact, in some cases it was actually less. I think the benefit you gain from the shielding from the sun was actually negated by the reduced ventilation. And finally, the cable backfill saw no tangible benefit up throughout the trial. So the main learning from the project is that the majority of our population of transformers has additional capacity that we can release, and all of these options are more convenient to the customer, less cost, and mean that you don't have to replace the transformer.